Now let's go back to data mining and say what data mining is really all about. I already went through some of this stuff in the training. Just a quick reminder. It's a search for patterns using modern, highly automated, computer-intensive methods. The term search automated is important, and we often say it's finding hidden information in data. So that's what we are doing in data mining. We're assuming there is a data set. We have no a priori information about it. We're clueless about it. That's the way I was a year and a half ago. I didn't know what those stats even represented or how they may possibly contribute to the outcome. And I decided to use data mining tools to help me understand what this is all about and what kinds of insights that I could get. The uses of data mining, of course, they happen in all sorts of different areas. This conference is a great example. There's all sorts of different terms employed by data mining and a whole bunch of different areas where it's used, including sports analytics. So that's kind of one of those things that I wanted to show. Now, the next part is important in the sense that in the modern data mining paradigm, we elevate the importance of the data set to the throne. I mean, that's basically the king. That's what we treat as the ultimate authority, and that's where the rest of the insights are coming from. Now, if you think about it, it's very different than conventional stats when the data was lying out there, and you as analysts would impose a model based on either some science or your assumptions, or for the lack of any other alternative, you just say, okay, it's a linear combination or it's some kind of other model. So in data mining, the whole paradigm shifts, and now we only ask questions. We look into the data and see what the data tells us, and we will make no assumptions. And there's a huge difference in that regard, between data mining and all of the conventional schools of statistics. Now, Falk Huitman gave a very interesting talks yesterday. I just happened to be sitting in this room with Ilya, helping doing introductions and all of that. And we had some interesting discussions. He does a lot of research, environmental kind of development and so on. And he introduced this concept that in statistics, we have frequentist school of statistics, we have Bayesian school of statistics. Those are two foundations, and everyone knows that they're kind of hands with each other. They don't really like each other for the most part. They always say, oh, you're wrong. No, you're wrong. It's like, like two kids in the room. What is interesting is that they both come from the classical foundation of statistics, and what we have here is the emergence of a third school that says, okay, forget about all of those assumptions to begin with. I don't care about priors, distributions, or all of that. I learn from the data. The data gets larger and larger, so we're essentially dealing with a whole new school of statistics, the way I see it, the one that focuses on the removing of bias from the massive volumes of data sets, removing a bias, meaning learning the modeling structure from the data it sees, and then as a side effect, perhaps we may be interested in learning about p-values or confidence intervals or imposing some kind of assumptions, that is, if they're even met, and it's not really important to us. What we want is to understand the signal, use it to make future predictions. We're also realizing that the world changes. It's never static. It's very dynamic, and you can either spend a lot of time perfecting your classical techniques, working with all of those approaches in order to figure out, okay, what's the signal in there, and then only to realize that you spent a month or 2 months of work, and now it's no longer applicable. Everything changed, and now you have to redo it again. So the time component is very important. So sometimes you just say, okay, give me something, give me now. I cannot wait to get the next kind of iteration or justification or test through the assumptions. And even if may not give me the right underlying kind of proper formal statistical paradigm, I don't care. I can still give you predictions in order to detect certain event before it happens. So that's a very important thing. So data is the king, and Of course, as a side effect, what it means is that the success of data mining now depends on the quality of available data. The garbage in, garbage out, famous principle. A lot of our work is dedicated not just understanding the signal that we find in the data, but also figuring out whether it makes sense. Because once you elevate data set to the point of most kind of authoritative source, you're also running into the danger of not having the right data or having the wrong insight. So there's always something to keep in mind.